and then we'll pick back up with that after Thanksgiving. So what we are going to be doing in the next 2 chapters is hypothesis testing. Basically, we will have a hypothesis, like I believe that, I don't know, the average grade in the class is this. And then we'll have an alternative. So my alternative might be the average grade is higher than that, or the average grade is lower than that, or it's not equal to that. And then we'll be testing to see if this is true or not. So a few things that we're going through. First, we're just going to jump in with an example. A friend wants to play a simple coin flipping game. If the coin lands heads up, you win. If it lands tails up, your friend wins. So after 5 plays, there have been 5 tails. Is your friend cheating? What do you think? What's the probability of that happening? How would I find that probability?
1/2 of it.
Right. Probability of tails is 1/2. It happens 5 times. So what is that?
It's 0, 3, 1, 2, 5.
Okay. So is it possible? Yes. Is it likely? No. So this is possible. But very unlikely. So either we would believe our friend is extremely lucky, or it could be cheating. We are going to look at, how convincing does this, or what kind of probability would convince us that our friend is cheating? How small does the odds have to be before I would believe that maybe this isn't fair? So first we just have a term when I'm talking about a hypothesis. That's just a statement regarding a characteristic of one or more populations. That's about your guess, what you think is true. So, for example, in 2008, 62% of American adults regularly volunteered their time for charity work. A researcher believes that this percentage is different today. So, according to a study, or let's just go through this one. What would my hypothesis be? What did the researcher believe?
62% of American adults regularly volunteer their time for charity work.
Okay, so originally we believed it was 62%. The hypothesis, the guess, the researcher thinks it's different. So it's not 62% anymore. According to a study published in March 2006, the mean length of a phone call on a cell phone was 3.25 minutes. A researcher believes that the mean length has increased. So what's the hypothesis this time? The mean is greater than 3.25. Okay, so it's just some kind of guess that you're making about your population. Just as a warning, when we're doing this stuff, it's because I don't have all the data from my population. What we're getting ready to do, this is called inferential statistics, making guesses about something. If you have all the data, is there any need to make a guess if it's different or not? No. So if you have the population, then we're back to descriptive statistics. All the stuff we were doing, mean, median, mode, all of that, just describing our data. It's when we don't have all the data from our population that we have to be able to make some kind of guesses. That's referred to as inferential statistics. We are making some inferences about our population. So to do that, we are going to do hypothesis testing. This is a procedure based on sample evidence and probability. So I don't have the data for the population. I'll be looking at my sample used to test statements regarding a characteristic of one or more populations. So we're going to take data from our sample to test some hypothesis about the whole population. Our steps, we will have to make some kind of statement about the population. We'll need to go get our evidence, and then we'll analyze the data. Now, you guys aren't actively going to be getting any evidence. I'm going to give you everything we need. So we are going to start in with the two hypotheses. You will always have a null hypothesis and an alternative hypothesis. The null hypothesis is denoted H sub 0. That's the statement to be tested. This is always assumed to be true until proven otherwise. Okay, that's like in those two examples that we had. The null hypothesis here would be that the proportion is 0.62. Until I've proven otherwise, I'm going to assume that it hasn't changed. Or here, my null hypothesis would be that the mean is still 3.25. Until I'm proven otherwise, that's what I'm assuming, that prior evidence there. Then we will need an alternative hypothesis. We denote that as H sub 1. That's what we believe is true now, and we're trying to find evidence to support. So for example, in this one, my alternative hypothesis, we believe that it was different. So it's just that the proportion is not 0.62. For this one, my alternative, we believe that the mean has increased, so it's greater than 3.25. So we have our baseline, our null hypothesis, which pretty much all of our examples is just going to be some parameter equals a number. So whether it's a proportion, a p, a mean, a standard deviation, we're going to assume something is equal to a number. Then our alternative will be either it's not equal to, it's less than, or it's greater than. So the null hypothesis, we have to find evidence to prove that it's wrong. If I don't get evidence, then I'm assuming that's still correct. If we get sufficient evidence, then that means we can believe the alternative hypothesis. So the three scenarios, there's two-tailed, left-tailed, and right-tailed. Two-tailed is when it's not equal to something for the alternative. That means it could be bigger, it could be smaller. So it involves both tails. Okay, left-tailed is saying your parameter is less than something. Okay, if you want to be smaller than this, that's to the left. So that's called a left-tailed test. A right-tailed test is saying your parameter is greater than something. So that's to the right. So two tails if it's not equal to, and then it could be either left or right, depending on if we're talking about less than or greater than. I think I kind of got ahead of myself. Here I had to actually write down the null alternative hypothesis, which I already did for those. This was the one that we said the proportion was equal to 0.62, and then the alternative was it's not. So is this left-tailed, right-tailed, or two-tailed? Two-tailed. What is the parameter being tested here?
Percentage of people.
Yep. So just your p hat was the thing we were testing on that one. Okay, so B, the cell phone one, which again I already did, we are talking about the mean equal to 3.25, and then we believed it's increased for the alternative, so the mean is greater than 3.25. So is this two-tailed, left-tailed, or right-tailed? Right-tailed. If you're greater than, you're above, so that's a right-tailed test. What is the parameter here?
Minutes on phone.
Just your parameters, like your variable that we're using. So up here we're using the p hat. Here we're using mean, your mean. C. Using an old manufacturing process, the standard deviation of the amount of wine put in a bottle was 0.23 ounces. With new equipment, the quality control manager believes the standard deviation has decreased. So what is my null hypothesis?
0.23.
So for standard deviation, we use sigma. So my null is that sigma is equal to 0.23. What is my alternative? Sigma is less than 0.23. So is this one-tailed, right-tailed, left-tailed, or two-tailed? Left is to the left, is less than. What's my parameter?
Standard deviation.
Yep, standard deviation, or sigma. So far, so good. In this section, we're not actually going to be conducting or testing any of these hypotheses. We're just trying to understand the notation, what the different things mean here. When we do this, there is always the chance of making an error, so drawing the wrong conclusion. There are names given for these. There's type 1 error and type 2 error. So type 1 error, we refer to that, the variable for that is alpha. So that happens if you reject the null when it's actually true. So it would be like me going to this manufacturing example and doing my process and saying, okay, the standard deviation is no longer 0.23. And so I reject that, but I was wrong. It really is. So type 1 is when you reject the null, you think it's not true anymore, but it actually is. The other type of error would be when you don't reject it, but you should have. I do my example, and I get that my standard deviation is still 0.23, but it's actually not. So type 2 error is when you do not reject, but the alternative is true. And the notation for that is beta.
Are there any cans in here?
Nope.
Any money or anything?
A bunch of slack. All right, so you'll have to know the difference between type 1 and type 2. Type 1, both of these you made a mistake. Type 1 is when you reject it, but you shouldn't. Type 2, you didn't reject, but you should have, okay? When I ask about the probability of making an error, that is called the level of significance, or the alpha. So when we get into problems later on, especially in the next section, we'll say, we're going to test this at the alpha equals 0.05. So that means there is a 5% chance of making type 1 error. So that alpha is the chance that we make a mistake. Because we know we can't ever be 100% certain. If I'm taking sample data, will it all ever match my population exactly? Probably not. So there's always that risk that my sample is going to be different and I'm going to be wrong in my conclusion. All right. For each of the following claims, explain what it would mean to make a type 1 error and what it would mean to make a type 2 error. So we are going to just write sentences to explain these two errors. So in 2008, 62% of adult Americans regularly volunteer their time for charity work. A researcher believes that this percentage is different today. So we've already talked about the null and the alternative for that example. Type 1 means what?
You say the original was wrong, but it was right.
Okay, so type 1 error would be the researcher concludes, so you reject type 1, so that means you're accepting the null hypothesis, so you're concluding the proportion is not 0.62 when it actually is. You rejected it. We said it wasn't 0.62, but it still is. Type 2, what does type 2 error mean?
Where you rejected, but you probably should have.
Right, we failed to reject it, but we should have. So the researcher concludes the proportion is still 0.62 when it is not. Is that okay so far? So why don't you guys take a second and do B, and then we'll talk about it together. So type 1 means you reject the null, but you shouldn't. So if we reject the null, that means we're going with the alternative. So the alternative was that the mean has increased, so we conclude that the mean is greater than 3.25 when it is not, or when it is still equal to 3.25. Maybe I should say that, when it, instead of just saying is not. Okay, type 2 is when what happens? You accept the null, so we're going to assume that the null hypothesis is true, but actually the alternative is true. So we're going to conclude that the mean is equal to 3.25 when actually the alternative is true, that it is greater than 3.25. You guys see what I'm talking about with these errors? Understand? One thing that we'll talk about this more tomorrow when we actually start testing some of these hypotheses. But when we test a null and an alternative hypothesis, we are never going to just say that the null hypothesis is true. Okay? We will look to see if there's evidence that it is not true. But otherwise, we can't just say, I accept the null hypothesis, this is true. All we can actually say is that there is not evidence that it's not true. Okay, what we're going to be proving is not that this is the correct thing. We're going to be basically trying to prove the alternative. So if I prove my alternative, great, we reject the null, the alternative is true. But if I can't prove my alternative, that doesn't mean the original statement was true, because that's not what I actually tested. All we can say is we failed to reject it. So we're just kind of getting into some of the terminology here so we are familiar with things. So our wording, we will never accept the null because we don't have the entire population, so I can't say for sure that it is accurate. All we can say is we do not reject. We fail to reject the null. Also, as the probability of type 1 error, which is my alpha, increases. Okay, so type 1 means I reject it. So as the chance that I reject it goes up, what's going to happen to the chance of type 2 error? It would go down because they're opposite things. Okay, so as probability of type 1 error increases, the probability of type 2 error, which is beta, will decrease. And vice versa. If the probability for my type 2 error is going up, that means there's a lesser chance of committing type 1 error. All right, last thing we're going to do is just practice our conclusion for these. So today we talked about how we'll set up a null and alternative hypothesis. We've talked about what the different errors mean. And final thing, we'll talk about the conclusion, how we will write that sentence when we actually get into testing these hypotheses. So according to a study published in March 2006, the mean length of a phone call, so this is the example we've used several times already, was 3.25 minutes. The researcher believed that the mean has increased. So remember, with this example, we've been saying the null was that the mean was 3.25. The alternative is the mean is bigger than 3.25. So part A, suppose the sample evidence indicates that the null hypothesis should be rejected. So we'll do this work and it tells me that I should reject it. How we will word that conclusion. So we can't say for 100% certainty because I'm using my sample, right? Not the population. So we'll just say there is sufficient evidence to conclude the mean length of a cell phone call is, and then my alternative was greater than 3.25 minutes. So again, we're not saying for 100% certainty. We are just saying there's evidence, there's enough evidence for me to believe this. Okay, I haven't proven it. I just believe that based on the sample evidence that was given to me. All right, second one. Suppose that sample evidence indicates that the null hypothesis should not be rejected. Okay, that means I did not have enough evidence to believe that this is not true. So that does not mean we accept it. We never accept the null. It just means that we failed to prove it was wrong. So there is not sufficient evidence to reject the null hypothesis. So for now, we just have to assume that the mean is still 3.25 minutes. Okay, so we've done really three things today. We talked about how to set up a null and alternative hypothesis. We talked about the types of errors that we make, and we're just talking about the wording of these things. We'll actually start doing this examples, testing these hypotheses tomorrow. Next piece, I'm going to hand back the tests, and we're going to go over those.